2, 1. Okay, so I did a video on the sine law and the ambiguous case, which is kind of knowing the angle and then two of the consecutive sides, or sometimes if you write it in reverse, you know two of the sides and then an angle, which is typically what teachers would write. I put a little smiley face because I like the acronym A.S.S. a little bit better. It makes it more memorable. Now, for that sine law and ambiguous case, I kind of went through the details and pointed out, when it can happen when you are given an angle and then two consecutive sides, that you have to be careful of the type of triangle that you're dealing with, because there's actually two triangles that can happen. Okay, I'm going to put up a link up above there to that sine law and the ambiguous case. And in this video, I want to point out to you how the cosine law actually kind of can help us. Now, it is a little bit more challenging to find using the cosine law what we need because of the fact that we're going to have to solve a quadratic. But this topic typically in terms of cosine law and the ambiguous case is covered in grade 10, maybe in grade 11. And by that time, you should know how to solve the quadratics, right? Okay, and now, so what was the problem with knowing an angle and then knowing two sides? The problem arose for us is in the case that our angle was an acute angle, so it was less than 90 degrees. And then once that happens, the two sides that were given could possibly lead to two different triangles that might be constructed. It might lead to just one, okay, unique one, or it may happen that there's no triangle that you can construct at all. So I'm going to give you those three cases, and I'm going to use the cosine law this time around to show you that solving that quadratic actually helps us to find out which of the three cases we're dealing with. No triangle at all, okay? Two possible triangles, or just one unique one, all right? And again, this was just for the case where that angle was acute. Now, our cosine law, so I wrote it out in here, is basically given like this, where you have a squared is equal to b squared plus c squared minus 2ab times the cos of the angle A. Now, here's the angle, okay? Let's say that we're assuming. It doesn't matter how you label these things. You can switch them up if you want to. But I like to label the angle, okay, with a capital, and then the side, opposite side, with a small letter A, and then you see the same thing, okay, so for these. Now, I'm assuming again, so that we're dealing with our angle. So let's say this angle A is going to be given to us, and then this angle is actually less than 90 degrees, all right? So that's the special case, the ambiguous case that we're going to be dealing with. So let me show you three examples and then how we're going to be utilizing this cosine law to try to help us along and figure out what kind of triangle are we dealing with. All right, so here it is. So I'm giving you arbitrarily. Okay, so notice here is my angle. So my angle is less than 90. Now I chose 60. Now it doesn't have to be necessarily 60, right? As long as it's less than 90. And then they have to give you two consecutive sides. So let's say they gave you these 15 and 10. And now we want to be able to see what will happen in this case. Does a triangle exist, right? Are there two possible triangles that can happen that we can get out of this information? Or is there only one unique triangle? Now, how you construct this triangle is up to you. So I always like to write this. Now, they may, of course, give it to you in reverse, right? They may give you the two sides, okay, and then an angle. So this would have been like side, side, angle. And, this is my A.S.S., okay, angle, side, side. So either one or the other, it doesn't matter, okay? Now, how you construct those triangles is up to you and how you label them. Now, of course, you have to label them accordingly to what is given. So, for instance, if I'm going to be constructing this triangle, so I don't know exactly how it looks like, okay, then this is kind of like this. Okay, so I would kind of draw this out. I just draw myself an arbitrary triangle, and it doesn't matter where you put the 60. I like to put the 60 here. But if you put the 60 here, then, and then you go along, then that means this side is 15 and this side must be 10. All right? So it doesn't really matter, okay, how you put these, okay, and where they are. We're interested in trying to find the rest of the information. Okay, so what I, instead, okay, I like to label it because I'm just so used to it. I'll label this side here, then this is 15 and this is 10. Okay, so that's what we have. Now, we want to find whatever else is remaining. Now, unfortunately, in this case, okay, so if this is, if this is angle A, this is side A, right? We call this, let's say B, this is B, this is C, let's say this is C. So if we have something like that. So if we have this piece of information given to us, then the cosine, typically you wouldn't really use in this case because, if you take a look what's actually given in this case, so you would say, all right, well, I mean, this angle, this side is giving. So, like if I go a squared is equal to, so I'm just rewriting the cosine law. This is b squared and plus, c squared. So this is what that would be. And then this would be minus 2 and I guess bc times the cos of the angle A. So if I plug in the information that's given, so I know, okay, so this is 10 squared equals 2. I don't know what b is, and that's where the quadratic will come. C is 15, so this is 15 squared, minus 2, and now b we don't know. We know c, right? So c is 15, and then we know cos of A. So it's cos of 60. So if you may remember, cos of 60 is a half, 1 over 2, right? So this is just going to be a half. And so now simplifying this, let's see what this will lead to. So I have 100, and this is b squared. 15, what was that, 225. And then minus, okay, so half, this will cancel that out, minus 15. So, and let's not forget that b, okay, right there. Okay, so I have that. Now, rearranging this, so I'm going to have a quadratic, right? Quadratic is going to have two solutions for b. And now we want to see what those solutions are, and then what happens to this triangle? How does this triangle actually look like? And then once we have the sides, we can certainly find, the rest of the angles if we wanted by using either the cosine law or the sine law once we have all the sides. Okay, so here, so if let's say I'm going to do this. So b squared, and this is minus 15b, and then 225, the 100 I'm going to bring over on the other side. So this is going to be plus 125. Okay, so this is what I have. Is that correct? Okay, now, so from right here, this is a quadratic. You can use the quadratic formula if you want to. I mean, you can try to factor it, but just use the quadratic formula. Okay, so, don't try to waste too much of your time. So the quadratic formula, okay, so don't forget. So it's minus b plus minus. Okay, this is b squared minus 4ac divided by 2a. So let me substitute all of those constants in there. Okay, the coefficients. So b, so that's going to be 15 plus minus here. And what do I have? So I'm going to do this in fast forward fashion, okay, just so that I can get the answers. All right, so welcome back. I just kind of simplified it. Notice that here, okay, so if I'm solving this, okay, what I'll get is under the square root, I'm going to get negative 275. What does that tell me? That tells me, so from solving quadratics, that there is actually no solution here. So there's no solution here, which means that this triangle that I tried to construct actually does not exist. It can't happen that you have an angle of 60 and then you have one side which is 15 and the other side is 10. Okay? So that triangle just doesn't exist because okay, if you would try to draw it out, okay, so that length 10, okay, will not construct an angle of 60 if you start to connect the lines together. All right? So this is kind of neat that the cosine law, although it's annoying because we're substituting it back into the cosine law and we get a quadratic, the numbers, the solution, actually tells us if a triangle exists or not. So if a triangle doesn't exist, that means there's no solution, right, to this. Okay, so that's neat. Now, here's the second example. So I'm still going to stick with 60 degrees. But now notice, I have, so my side is still 15, but then I've increased my side to 14. Now, what's going to happen in this case? So again, you can draw this out for yourself. This is 60, right? So angle, side, and side. And now what will happen in this case? So if I'm going to substitute this back into the cosine law, what will this give me? So again, as I'm substituting it in, so this is, it's kind of coming back from here. Copy this down, copy. Okay, paste it. So within here. Now, if I plug the numbers in here, so again, so my A, so this now it's going to be 14 squared equals 2. I don't know what B is. C is 15 squared minus 2 times 15. Again, cos of A, which is the cos of the angle 60, which is still a half. And then, let's not forget that B this time around. So now so I'm going to manipulate this and then try to solve the quadratic again and then show you what the solutions give us and what they tell us about the construction of the triangle. Is there still no solution, meaning no triangle? Or is there a unique solution to the triangle? Or maybe there's two solutions to the triangle, right? So I'll do that in fast forward fashion and then I'll come back and comment. So I'm just simplifying this and solving the quadratic. That's what I'm doing here. All right, so here it is. Notice now under the square root, I get a positive, which is 109. So that means, okay, so that I'm going to get kind of two solutions here. So I'm going to get 15 plus the square root of 109 over 2. Notice that's positive 100% because both numbers in the numerator are positive. Okay, so what will that give me? Now let's just compute. I'm going to just approximate. So it's around 10.4, right? So this 15 plus, let's say approximately 10.4 divided by 2. All right, so that answer, plus 15. Okay, answer divided by 2. So, this is about 12.72. So that would have been the length of that side B. So that we have at least one solution. Now, the other solution, okay, to the quadratic is 15 minus, right, the square root of 109, which I guess is, approximately 10.4 divided by 2. And 15 minus 10.4 is still positive. So, so this is going to give us two solutions here. So we're going to have 15, minus 10.4 approximately, and then divided by 2, which is around 2.3. So these, okay, notice I have two solutions to my quadratic if my side right here is 14. So what that is going to entail and what it's going to mean is that I either have, indeed, a triangle that looks kind of like this, right, where this is 15, 14, and then the other one was 12.7 approximately. So that's the longer one. Or I have a triangle, that looks like this, where this is smaller, right? And this is only 2.3, and this is 15, and this is 14. And that's kind of nice, and it comes out from the cosine law, where the cosine law, the math actually tells us the possibilities for these triangles that we have. So in this case, there's two possible triangles that might exist. And of course, we would need more information than just this to be able to decide which triangle are we dealing with, right? So whatever application you have to be careful. Okay, so which one did they actually give us? Because just knowing this, the angle and the side, or the side angle, is not enough, because now we have two choices for a triangle construction. So that's pretty neat from the cosine law. Okay. Now in the last example, so I'm going to make this side. I'm going to make this side even longer. Now you can probably kind of gauge, if you remember from the sine law, that this most likely, because now it's longer than the actual 14, it's longer than the side. So notice it's longer than 15. This is going to give us a unique solution, okay? Because, this side is actually longer than that side. So, I mean, I remember that from the sine law. I'm not sure if you remember that or not. But if it gives us a unique, so that means we should have only one triangle. That means when we're solving and using the cosine law here, that means our quadratic is going to have one positive answer and it should have one negative answer. And we can't have a negative answer, right? Because we can't have a negative side. Okay, it doesn't make any sense. So that means there's only one unique side. Let's see if that happens. All right. So I'm going to plug everything back in here and do it kind of in fast forward fashion, and then come back and comment. All right. All right, so welcome back. So this is what we have. Okay, so when we're solving the quadratic, hopefully I did it right. So we have, 15 plus minus is going to be the square root of 925. And so that's positive. Now that equals to approximately 30.41. So our answers, okay, so if we try to do this, it's going to give us two answers, right? We have a positive answer, which is going to be, I guess, 45.41 divided by 2. So this is for sure an answer that can happen, right? We can certainly have a side which is positive. But now here on the other side, notice if you do 15 minus 30.41, so if I do 15 minus 30.41, so that's going to give us a negative answer. And this cannot happen. So the math actually throws out for us that we do indeed have just one unique answer. So 45.41, that side would have been my third side. So if I'm going to be drawing out my triangle, now this is definitely not going to how it's going to be. Okay, if this is 15, this one was, I think it was 20. Okay, so this is 60. So that means that this side right here, okay, would have been 45.41 divided by 2, which is approximately 22.7. Okay, so this is 22.7. That's that side, and there's only a unique answer to this. So that's pretty cool. I like that this cosine actually shows us that in this ambiguous case, the actual solutions. Now, it's annoying because we have to find the quadratic, but you can certainly use this tool if you wanted to, right? So if you forget the sign and like, oh my gosh, I can't remember like what it was, then you can just go back into the cosine, and then you're going to have to deal with the quadratic, but the quadratic at least will tell you, do you have an answer or not? So for example, in the first one, we couldn't even construct a triangle that had an angle of 60, and then a side of 15 and another side of 10. And remember, this is for, angle side side or side side angle. That's the ambiguous case, and then the angle is less than 90. right? Because if the angle is greater than 90, in those cases, just go ahead and use the sine law. The sine law will tell you exactly what you need to know, because as long as the triangle exists, there's only a unique case. If the angle is 90, then you might as well just use the trigonometric ratios directly, because it's a 90-degree angle. So you can find whatever it is that you need. But if the angle is less than 90, you can use either the sine law or cosine law, but you have to be careful in constructing that triangle. All right? So I hope that this is useful, and it gives you an example, in a sense, of how you can think about utilizing the cosine law in the case of this special case. All right? Okay. Thanks for watching, and we will see you in a future video.